Independent and dependent probability. So, to calculate probability, we identify the separate decisions, write a fraction for each decision, and multiply the fractions. For example, we're flipping a coin and rolling a 6-sided die. What's the probability of flipping heads and rolling a 3? Well, the probability of flipping a heads and rolling a 3, well, there are two separate decisions being made here. So I'm going to write two fractions, one for each decision. There's one, there's going to be the other. Now, the probability of flipping a heads is 1 out of 2, and the probability of rolling a 3 is 1 out of 6. So we multiply those together and we get 1/12. You've spelled the word math with Scrabble tiles. Your brother hits the board so the letters are scrambled. What's the probability it still says math? Well, there's a choice being made for the first tile, second, third, and fourth. And if the first tile is an M, there's a 1 in 4 chance. Now that we've taken out that M, now there are 3 choices left, so there's a 1 in 3 chance that the next tile is an A. The next tile, there's a 1 in 2 just between the T and the H, and now the H is the only one left, so it's a 1 in 1 chance. Multiplying these all together gives 1 out of 24. This is an example of dependent because when you choose one thing, it affects the others. But flipping a head has nothing to do with rolling a die, so this is independent. Lee has 12 black socks and 6 white socks in his sock drawer. He grabs socks while it's dark so he can't see them. He gets 2 black socks. So we have 1, 2. There are 2 decisions being made, one for the first sock, one for the second. There are 12 black socks for him to choose from the first time, and total there were 18 socks. So 12 out of 18 is the probability that the first sock is black. I got 18 from 12 plus 6. Now, the second sock, we lost 1 sock here, so 12 minus 1 gives us 11 black socks left out of 17 total socks. And when we multiply these together, we will get 22 51st is the probability that he gets 2 black socks. This is dependent because once he pulls a black sock out, he is not going to be able to pull out the exact same black sock. It changes the probability for the next one. Cole's ice cream stand serves 16 different flavors of ice cream, 3 types of syrup, 7 types of sprinkles. Jessica gets ice cream for her picky friend. It only has one thing that's right. What's the probability she got the right order? Well, there are 3 decisions being made. 1 for ice cream, 1 for syrup, and 1 for sprinkles. So we'll have 3 fractions that we're multiplying together. 1, 2, 3. There are 16 choices for the ice cream, and because she's picky, only 1 is right. 3 types of syrup, and only 1 is right. 7 types of sprinkles, and only 1 is right. So we multiply these together, and we get 1 out of 336. You remove 3 marbles from the box of 24 marbles shown below. This is independent. This is independent because each choice does not affect future choices. Now you remove 3 marbles from the box of 24 marbles shown below. What's the probability they're all green? So we have 3 marbles that we're removing, so that's 3 decisions. Each decision, well, the first time we have 24 marbles in the box. And how many of them are green? 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 24 are green. Once we've removed 1, now there are 7 out of 23 total marbles. We move a second one. Now there are 6 out of 22 total marbles. So this is dependent. This is dependent because once we remove 1, it changes the probability for future ones. So this will be 7 over 253. One more. You guess on every question on a 20-question multiple choice test, A, B, C, D. What's the probability you get 100? What's the probability you get a 0? So there are 20 different choices being made. 20 different decisions. You're making a decision for problem 1, for problem 2, problem 3. So you might think that we're going to multiply together 20 different fractions, but that's going to become really annoying really quickly. Luckily, they're all going to be the same fraction. They're all going to be 1/4. There's a 1/4 chance of each one being right. So rather than doing 1/4 times itself a bunch of times, you can do 1/4 times itself a bunch of times. That's what exponents are for. So 1/4 to the 20th power, that is going to be approximately 9. And when I type it into the calculator, what I'm seeing is 9e negative 13, which is the same thing as a decimal point followed by 12 zeros. I think I've done 9, 10, 11, 12, and then a 9. That is the probability you get a 100. Now, for getting a 0, there are still 4 options per question, and there are still 20 questions. It's just that 3 of those get counted as wrong. So, when we multiply this out, we're going to get somewhere around 0.003. Most of the time, you're not going to get either of those scores. You will neither get a 0 nor a 100. Usually, you'll get somewhere between those two. But there is a possibility, even if it's very, very rare, to get a 100. And there's a possibility, even if it's pretty rare, not quite as rare, to get a 0. That's how we deal with independent and, these are independent events because each question doesn't change your answer for future questions. Thank you.